Alright, so here we are back for day 2. A little bit more on polymer techniques. Before we begin and before I introduce myself, I'm going to take a moment to teach you something important. This is my cell phone. It is a timer that's reminding me that the sparging that we talked about last time is done. I took off my glove. You never want to touch your cell phone with your gloves on. This is something you put near your face. You don't want the chemicals that are on your gloves, on your face, on your ear, in your hair, on your clothing. We'll have our cell phones in the lab. That's pretty much to be expected these days. It's a good timer, it's a lot of things, but it's not a good thing to touch with gloves. So take off your gloves when you need to answer your cell phone. Okay. Now that the teaching moment is done, again, I'm Professor Stephanie Sidlick in the chemistry department here at Carnegie Mellon, and we are talking about the molecular basis of polymer mechanics in my course this spring. This is day 2 of our laboratory module, which involves polymer purification. So today, last time we set up an air-free synthesis of our polybutyl methacrylate, and here I have a completed synthesis, so it's gone for 24 hours. And the first thing you want to do, which I already did, is pick it up out of the solution where it's stirring. We're heating it at 80 degrees C, but the first thing we need to do to purify it is to add chloroform, and chloroform is a carcinogen. But as long as we handle it in the hood, that shouldn't be an issue. But chloroform boils at 65 degrees Celsius. So if we added chloroform immediately to the heated solution, it would boil up and splash out. And so I just let it cool for a few moments before I did that. So now we'll remove the nitrogen line. So again, this is our nitrogen line, and we'll just close this all the way. We will remove this. About 30 milliliters of chloroform. So chloroform, the addition of the chloroform, you can basically eyeball the amount. It doesn't need to be precise. So we aren't going to use a syringe. I'm just going to pour a little bit, because this is pretty heavy, into another glass. Alright. I'm just going to add this here. So as I mentioned, chloroform is carcinogenic. So if you get a little bit on your gloves, you do want to change your gloves as quickly as you can. So what I'm doing right now, I'm putting the stopper back in, because we're just going to let this stir for just a few minutes to make sure everything is dissolved. You don't want to do that. So we will hurry up our stirring by using a little bit of swirling like this. Put this here. And I did get a small amount of chloroform on my gloves, so I'm going to change my gloves. up. Oh, no harm done. You do, rather than putting this in the wastebasket right away, leave it in your hood for a little bit because there are those chloroform vapors and you want them to evaporate. And if we put them just in the trash, they'd evaporate into the air we're breathing. Okay. So in the meantime, while that's stirring, we are going to set up our column. Set of column that we'll be using in this class. So organic chemists tend to use a really long column. In polymer chemistry, we tend to use plugs, which are a little bit shorter. Basically, the difference is in a column, you collect fractions and separate fractions of a product, whereas in a plug, you pour all of your material through and collect everything that comes out the other side. For this, we'll just be using a 50 ml syringe. It is a plug that will be running, so you don't need to use the regular glassware for this. And conveniently, we're going to be running through just about 30 mils of silica, so it's conveniently bunched. First thing we want to do to set this up as a column, remove the plunger. Sometimes it can be a little bit tricky to take it out at the end. And then we want to block the bottom so that silica, which is a sand-like consistency, so it doesn't get out. So what we use for that is a cotton ball. And you don't need the whole cotton ball, just a little piece of it. We're going to poke that down in there. And what I have found works really well for this is to wet it. So it's kind of fluffy like that. It hit or miss whether or not it is going to move. So we will make sure that it's wet. Now I'm going to take the plunger back out and I will put it in to basically kind of mash down. We want to make sure the cotton's blocking the hole. Got a little violent there. And try and get as much of the chloroform into this flask to collect it as you can. You definitely don't want to be shooting it outside the hood at your lab partners. Okay. My cotton's already on the move. Once you're sure that your cotton's not going to move, you can add in your silica. you want to be pretty careful about, just because if you get silica in your polymer when it comes out the other side, you're going to have to run the column again. And so you want to do it right the first time. I'm nervous now since my cotton ball moved, so I'm just going to add a little bit more wet. The wet cotton ball is much less likely to move. Slowly add the silica, tapping a little bit. Like I said, we need about an inch of silica to get out all of the copper. So basically what's happening here, what we're doing in this step, is removing the catalyst, the copper catalyst. A little bit of extra chloroform here. Make sure you're capping your chloroform when he's not in use. We're going to put this over in our chlorinated waste. Nice solution of polymer over here. All we do, uncap it, and very, very gently, so you don't disturb the surface, very gently pour this on. So here, you can see it's, by waiting for gravity, this column doesn't run very fast. There are a few things that you can do. One of my favorites is to use positive pressure. And so what we can do is take a balloon, fill it up with air, and then cover the mouth carefully. Cover the mouth of the column with the balloon. And now the one thing that you want to be sure with this, so if the balloon comes in contact with any solvents, it will pop, which can be pretty startling. So you want to make sure that you're nice and careful. There we go. So now you can see that you're starting to push your polymer through the column. You can start to see that go. And we're just going to wait for the column. Like I said, this will help it along. You can also use a plunger to push it through. That can be tricky though. I like speed, but with all the negative pressure and the pressure buildup with the plunger that you put on, it can be a little bit risky. You can mess up your column. So I think this is a little bit safer. You can also just wait for gravity, but it will take a very long time. You probably want to just let it go overnight. Okay, Okay, so our polymer came all the way through our plug, and so now we have our nice concentrated solution of chloroform here. What we're going to do is we are going to precipitate it into methanol. And so, pour this out. And take some methanol. You can see there was a little bit in here already. It's already starting to precipitate. So for a good precipitation, you want 10 times the amount of volume of your bad solvent, in this case methanol, as our good solvent, which is chloroform. And then you just slowly want to add your solution. See it come right out, nice and cloudy. It's white, cloudy stuff that means you made a good polymer. You can see, very white, so we have a lot of good polymer in there. And now all we'll do is transfer this to a centrifuge tube, and we'll centrifuge it to collect the solids at the bottom. That's all for today. Thanks.